Now for part B, we have an expression in the numerator and the denominator that needs to be factored. So let's do these one at a time because they are one of the more difficult ones to factor. So let's rewrite both of these on their own and factor them. So 2x squared minus 3x minus 2. So we need to find numbers that multiply to negative 4 and add to negative 3. So that would be 4 and 1. And I need to multiply to a negative and add to negative 3. So that's going to be negative 4 and positive 1. So then this would become 2x squared. And then I'm going to replace the negative 3x with those two numbers. So negative 4x plus 1x minus 2. Factor this part on its own, and then this part on its own, so factor by grouping. So this would become 2x, start a bracket, and then we have x minus 2. And then for this one, there's really nothing to factor, or nothing in common, but what we do is we make sure that we take out 1. So we'll say plus 1, start a bracket, and then we have x minus 2. So our factors here are x minus 2 and 2x plus 1. All right, one down, one to go. So now we'll take a look at the denominator. So that one, we'll just write again. So 3x squared minus 5x minus 12. So I'm looking for numbers that multiply to negative 36 and add to negative 5. So it looks like we want to use 9 and 4. And then this would need to be negative 9 and positive 4. So now we'll write this again. So we'd have 3x squared minus 9x plus 4x minus 12. And then we'll factor these first two and then the last two on their own. So for the first part, we will have 3x and then x minus 3. And then for the second one, we'll have plus 2 and then, plus 4. And then we'll have x minus 3. So then our factors here would be x minus 3 and 3x plus 4. All right, so we did the hard work of factoring those. So now let's take another look at this. So here's what our factors ended up being. So now let's draw in our vertical asymptotes. And where do we find those? Well, looking at the denominator of both of these. So in this case, our first one here would be at x is equal to negative 4 over 3. And this would be at x is equal to 3. So if we're writing this on here, this one here, this asymptote would be at x is equal to 3. And the other one would be at x is equal to negative 4 over 3. All right, so now let's use our graphing calculator to help us out, but then we'll kind of check if this makes sense with our factored version along the way. So if you graph this in your calculator, like shown here, using appropriate window settings so that you can actually see it, then what you'll want to do to find the y-intercept is press the trace button and then just type in 0 unless it's already on 0. And then it should show you that the y-intercept is at 0.17 approximately. All right, so that's what our y-intercept is. But we didn't even really need that, did we? If we want to find the y-intercept, well, to find the y-intercept, you would throw 0 in for x. Now again, you could use this equation to do that, but this one's nicer to use because I can even do this one in my head, because if you throw a 0 in for all these x's, all those terms disappear. And I just end up with -2 over -12, or 1 over 6. That's even better than the answer we found with your calculator. So we'll have a y-intercept of 0, comma, 1 over 6. All right. Now let's look at the zeros, or the x-intercepts. So on your calculator, go second, or calculate, and then 0. Now you'll click to the left, click to the right of where you think it is, and we get a 0 at x is equal to -0.5. Now, does this make sense? Well, yeah, that actually comes from this, right? Because if this was equal to 0, then, so you could make a little equation if you like, 2x plus 1 is equal to 0. Solve for x, and you do in fact get -1 over 2, or -0.5. If you look for your other x-intercept by following the same steps, then it's at 2, and yeah, that makes sense as well. This would be at x is equal to 2. I should have wrote x is equal to in the last one. So before we move on, yeah, let's write that down. So our x-intercepts were at -1/2, comma 0, and 2, comma 0. All right. Another thing that's going to help us for sketching this graph is to find this local maximum. We don't really know how high this thing comes up. So if we want to accurately sketch this, I want to know how high to come up here. So to do that, we're going to go calculate on your calculator, and then we're going to find a maximum, and then click to the left, right? It's asking left bound, so click anywhere to the left, click anywhere to the right, and then it's asking you to take a guess. And then it says that we have a maximum at 0.7 and 0.22. Now this part, you aren't going to have to find this algebraically. This would be a calculator thing to find any local or local maximums or local minimums. All right, so that's going to help us though. Now let's kind of fill out a few more things that we've kind of found along the way. I wrote the vertical asymptotes over here, but let's write it there as well. We had x is equal to -4 over 3, and x is equal to 3. What about the horizontal asymptote? So in this case, the degrees were the same in the numerator and the denominator. So all we had to do here was look to our coefficients. So in this case, our horizontal asymptote isn't going to be at 0. It's going to be at y is equal to just the ratio of the leading coefficients, so 2 over 3. And again, we could have found that from here as well. Okay, now let's write the domain and the range, and then we'll see if we can sketch this. So the domain would be excluding our vertical asymptote. So that's going to be x such that x cannot equal -4 over 3 or 3. Now our y-intercept, and in this case, yeah, our y-intercept, maybe this would be a little easier to figure out our range after we sketch it. So if we sketch this graph, just kind of following your calculator there, and we knew that we had our horizontal asymptote at 2 over 3. So that would be somewhere along this line. That was good till there. Then we have to be, well, everywhere above this line for these sections of the graph. But then for this section of the graph, we're going to be everywhere below that local maximum. So we need to write this one out a little different. So we're going to have to write it in two parts. So we'll say y such that y is, and then we'll look at this one first. So y has to be lower than that point. So where was that point? Well, that's the one we found here. Our maximum value was at 0.22. So y is less than or equal to 0.22, or y is, and now let's think about what y would have to be. Y would have to be just greater than this point. So I know it looks like it's approaching some number higher than that, but that's just because our window setting doesn't go far enough to the right or left. It would be this red line I've drawn here. So it has to be greater than our horizontal asymptote of 2/3.